The following is an explanation behind a new data type I call a null-terminated integer. Basically, it is a way of representing a number of any length, no matter how large, giving just the bytes that make up that number, and then terminating it with just a null character. So the idea is none of these bytes can actually be 0. Only the null termination character can be 0. So your combinations are 1 through 255 for each byte. What that allows is for you to have, instead of, for instance, a 64-bit integer, which has 8 bytes, it has a ceiling of that insanely huge number. You can actually represent any one of the numbers in that combination with far less bytes. Like, for instance, if you wanted to represent 0 to 254, you could do it using 2 bytes with this null-terminated integer instead of 8, and that would give you a savings of 6. So for each one of these sets, you have a different level of savings, except for when you get to the last one, and also the ceiling for the amount of bytes is lower than what you would have with a normal integer number, because I'm only going from 1 to 255 instead of 0 to 255, because 0 is always going to be the termination character. So you may ask, why would you need this kind of data type when you can just represent some insanely huge number with a 64-bit integer? Well, that's a good question, but I don't want limits. This is all about removing limitations. For instance, if you tried to represent a file size with a 64-bit integer, your maximum would be that there. So with this other software that I got, I needed to represent file sizes of any length because I'm using a recombinant file compression program, which allows for infinite storage space. So it being infinite, your maximum representable numbers have to also be infinite. And in this case, I would tag on the size of the file to the trailer and actually read it in reverse from right to left. And if you want to know how to convert back and forth between a null-terminated integer and a value, it's actually pretty simple. In this case, my file size is 16,581,374. So I know just for starting out that the bytes that represent that number is 255, 255, 255, 0. Going from 0, 1, 2, and then a null termination character. Now to get these to get the value, to make sure that these bytes actually equal this number, it's actually pretty simple. You start off with your byte value, 255, subtract 1, and multiply it by, this is the number of combinations for that sequence. 1 to 255 is 255 combinations. So 255 to the power of that byte number, in this case it's 2. So you take that, add it to the next one, which is basically the same thing, except for you're raising the combinations to the power of the byte number 1, and so forth with byte number 0. Add all that up, and you get 16, 5, 8, 1, 3, 7, 4, exactly what we said here. So anyway, I would write those in reverse to the trailer of a file. And then if you want to go back from a value back into what bytes make up that value, it's actually pretty simple. Well, sort of. What you got to do is you have a starting value, which is the value you want to convert. Now, before we get into it, there's a couple things you have to do. You have to determine your byte weight at each point. So the byte weight basically breaks down to this. On byte 0, every one of those bytes that make up byte 0, or every value, has a weight of 1. So if the value was, let's say, 5, then that byte's value is 5 times 1, which is 5. Now if you're on byte 1, which is the next one, every one of those bytes has a weight of 255. So if you have a value of 1, you're taking and adding 255 times that 1 to everything else. So it has a much higher value. So that's your byte weight. And then, of course, your byte numbers, 0, 1, 2. Okay, so now that that's established, you can get the individual byte values. So we're going to start with the first one. Basically, it's going to be, oh, and by the way, this is combinations raised to the power of the byte number for your byte weight. Alright, now, byte value, you're going to take the integer half. That means you're going to disregard everything past the decimal place, and you're not going to do any rounding. But you're going to take the integer half of this stuff right here, which is remaining value divided by byte weight. Well, for us starting out, our remaining value is our starting value, which is 16,581, blah, 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 blah. Alright, so we got that, and we're dividing it by this number here, which is our byte weight for that byte that we're trying to figure out. And when it's all said and done, since we don't offset from 0, we offset from 1, you have to add 1. So that gives us 255. So now we can't just leave it there. We have to next determine the remaining value for the next sequence. So you take your previous remaining value, which was your starting one, and you subtract the number, or the byte value, minus 1, because we got to offset it back, and multiply it by your byte weight, which is over here. And you get this. This is your remaining value that you're going to work with for the next set, which is right here. Your remaining value divided by your byte weight, yada yada, and you end up with it, same characters that you got here from that value. So that's how you can convert back and forth between a null-terminated integer and a regular integer, whether it be 64-bit, 32-bit, or what have you. Advantages are there is no maximum number. The only limitation for a null-terminated integer is the amount of storage space you have. So yeah, no limits there. It's 1 byte behind in lengths for any other integer. And you have 1 extra byte, which is wasted as your null term. Other than that, being able to represent numbers of infinite length, or being able, not having a length basically, to what you can represent is a plus, as well as the byte savings you get from representing it with a smaller number. And that is all.